In Unit 3, we're going to talk about quadratic equations. Just as a reminder, what we've talked about up to this point have been linear equations, so they've looked something like this. That was the parent function. Sometimes we see it in slope-intercept form, and it looks like this. We might see point-slope form. That looks something like this. We might see standard form. That looks something like this. But these are all forms of linear, and the reason that they're linear is because when you graph them, they make a line and they have an x to the first power. But in this unit, we're going to talk about quadratics. So if you'll notice the standard form for quadratics, with the x comes a squared. So anytime we see x squared, we're going to know we're dealing with a quadratic function. And we've talked about what functions are. Functions pass the vertical line test, have exactly one output for every input. So this is just another function like a linear function, but it has different things that happen. So this is standard form. What I'd like for us to do first is talk about graphing the parent function. So we're going to graph the parent function y equals x squared. So on your note sheet, make a table, and we will graph it. We want to make some points for x that are negative and positive. So I'm going to use -2, -1, 0, 1, and 2. I'm going to try these values for x and see what I get for y. So I'm going to start with 0. If I put 0 in for x, I get 0 squared equals y, which is 0. If I go up here and I put a 1 in for x, 1 squared equals 1, so if x is 1, y is 1. If I put 2 in for x, I get 2 squared, which is 4. So when x is 2, y is 4. Now let's look at the negative numbers. If you put -1 in for x, remember that when you put a negative number in and take it to a power, if you do that in your calculator, you have to make sure you do it in parentheses. -1 squared is +1. Same thing if I put -2 in for x. -2 squared is +4. So let's graph these points. And if you need to, pause the video. I'm going to move through them, but if you don't have time to write, pause the video and do writing and then unpause. So I'm going to plot these points. 0, 0, 1, 1, 2, 4, -1, 1, and -2, 4. So you can tell on this one, oops, I want 5 on this one. You can tell on this one, oh, I was right, that we don't have a constant rate of change this time. I'm not going up 1 over 1, up 1 over 1. I go up 1 over 1 here, but then to get to the next point, you go up 3 over 1. So a quadratic formula does not have a constant rate of change or a slope like a linear function does. Instead, the graph looks something like this. And this is called a parabola. And you did talk about it some in Algebra 1. We're just going to go a little bit more in depth in Algebra 2. So this is a parabola. It's the graph of a quadratic function. The point right here is called the vertex. And if it's a parabola that opens upward, it's the very lowest point. And if this was a parabola that opened downward, it would be the very highest point. So the definition for vertex is the highest or lowest point of a graph. And I should probably say the graph of the parabola. Through this point, if you draw a line, the parabola could fold over on top of itself. And so we call this the line of symmetry or the axis of symmetry, because if you folded over this line, the parabola would graph right on top of itself. So the axis of symmetry is the vertical line going through the vertex. And if you think about this, this is one you'll probably want to memorize because you're going to use it a lot. Notice if I put 1 in for x, I go up 1 squared. which is 1. If I would put 2 in, I would go up 2 squared, which is 4. If I put in 3, I would go up 3 squared, which is 9. 4 would go up to 16, 5 would go up to 25. So you can see how this parabola would keep going and never stop.